Hello everyone, thank you for clicking on this, for watching this whole series, Houdini for Games in Unreal Engine. We're attending DoubleJump Academy's course, Houdini for Games in Unreal Engine. We are currently in week 4. It's an 8 weeks program. If you want to check it out, definitely check the link below. You will get a discount on their work. My part of this is documenting my authentic experience at attending their workshop. And it's been overly positive so far. Okay, we have created the Let's Learn Houdini series that started even before we attended the course or the workshop. It starts from part 1, day 1. Check that out if you're curious how we came to that level. We started learning around 5.5 weeks ago. Anyway, not to take a lot of your time. Yesterday we created this VEX system. I just did a small review, so I revisited what we've been working on yesterday. It took me around 30 minutes, I would say. And now we're basically starting to continue from where we left off. I didn't want to record this because you can basically just check the video from yesterday, but I had to warm up a little bit for today. So yeah, we have all those stuff working now. It looks good. But we still need to spawn to make those point spawn thingy work. Okay, let's see where we're coming from here. This is the workshop itself. We have completed 53%, pretty good progress so far. Yesterday we have completed the 3 spawn region. So we'll click here and actually click on complete and continue. So we could save our progress. And then we basically have we have now these 3 videos to watch today. That is at least my goal for today. So hey, thanks for the follow, appreciate it. For today we want to have the 4th video, the 5th video, and the 6th video completed, hopefully, if we just keep grinding today. And so we have select spawn point. These will be the points that we will select and spawn our system, or our infection slash what is it called? Infection slash vine. And we have the connect curves, which should connect this point to the other, and then the noise to the curve, so we can have, you know, this type of effect, so it could show some variation. And if you're curious what I mean, right there you see we want that effect to work. That is provided by DoubleJump Academy, like I mentioned before. This is their file that they provided, where we could revisit the system and look at the VEX if we missed the spelling or whatever, or just review how they've done it before we start, or just look at the parameters on our own time without going into the course content, because we just want to look something up. So it's quite helpful, and I really like that addition that they just provided actual files. Okay, so this is not my work. This is Grayson's work, and we're building that from zero here. We're pretty excited about it, so we'll see how that will work. So yeah, that is the progress for today. We'll watch those 3 videos. We'll see how to spawn the point, connect the point, and add some noise to the point. Okay. All right. That sounds good. I'll pause the recording now, and we'll see you after I've learned a thing or 2. Okay. So what are the next steps? First of all, what the heck is this red spot here? What is it doing? Okay, that is our search. These are the points that our search is covering. If I go now into the wireframe, we see that the points, the vertices, are actually getting colored here. Okay, so if I go with minimum search distance to 0, it will go all the way to where the point is that the search is coming from, which is determined by other factors. We saw that yesterday. Okay, so that thing here determines how much of minimum search we want. So for example, why would we need this? We would need this if we don't want things to go too near to it, and we can have those parameters working inside of the HDA in Unreal as they generate, and this is our maximum value right there. It's funny that the actual trajectory of the position is changing due to the Yeah, nah, it's fine because the maximum search distance is the one that is determining which point it's calculating from, and which point and at this random loop as well. It's very important because the loop is taking a point each and every time it loops. So it's taking a random point for now to calculate from. And that random point is being calculated through the max search distance in a float, even though it should be a vector. So that's, I think, why we're getting that value here, due to the fact that this value here is a float and it's taking from a distance value. So it's taking the average, I think. It could be wrong. Don't quote me on that. That's just my own understanding of the whole thing. Good. Now we have the minimum alignment that allows us, if we put it lower, to have basically the half of the value, the middle value of the trajectory, and this one from the inside out, basically. So we don't want it to connect all the way because we don't want the point, the eventual point it searches for, to be inside. We want it to be a bit outside, and we can give it a bit more trajectory in that manner here, or in that direction, basically. And that's not the only thing that we will do, but also what we will be working on mostly is that list right there, the I list, so the integer list of the final point search that we together yesterday have given a color. What does that mean? What the heck does that mean? Okay, so what it's doing, the FPTS, is taking, it's creating, it's like someone that's having a notebook and it's creating a list of all the numbers of those points. So all those, it's taking a list. Let's take a look at their numbers. So it's saying 8066 is part of the search. 8037 is part of the final search. 8038, etc. Right? We visualize that, and we could also look at it deeply inside of the attribute itself. If I go here and I look for FPTS right there, if I click it, it should give me the point that is listing all the final points that we want to take this from. So what is the next step? We see here generate random value. The generate random value should basically create a random number that basically fit, that we will make it fit the random value inside the length of the attribute FPTS. So we will see how that will work. I can't explain it one-to-one. I'm just quoting Grayson here. And then all of that will go into the ability to round it down to the closest point. So we'll create a random value, I think, that would choose either from these group of points or these group of points, and we see how that will be done. My current understanding is that we will definitely be working with the rand here, this type of thing that creates a random number between 0 and 1, but we'll see how that will work later, and we will for sure call out our we'll call out a new for each, I think, and also we will that for each will basically work with, yeah, of course it's gonna call it an integer, we'll call it XYZ, it doesn't matter, I'm just guessing right now, and then it will take from our IFPTS. Could actually put that random value right there as we go, but we could also separate them just for our own understanding. So I at FPTS, so it will take from the FPTS itself, and then it will start its own it's on, what is it called, it's on for each, and we'll put that random in here. Look at me coding. Wait, what happened there? Ctrl B, I think. Yeah, and this had deleted everything because this doesn't make any sense for the logic. But yeah, this is what I think we will do roughly. Let's see if that's true, and let's dive into it. So, people, what's my mic now not working? That's funny. Okay, We were muted for some time. That's fine. I sometimes mute because I want to drink water and then I forget to unmute myself. Fine. Okay, so what did we do? We brought our notepad. Okay, let me just delete everything in here, right? And let me show you what we worked on. And I will also delete this. I have it in my head. Just in case, we'll just keep it here. All right, so let's see how we generated that random value. Okay, so what we did is we brought the value from the seed here. If you remember, we created a seed, and we want that same seed to control the seed of the point selection. So if I right click and I copy the parameter, right, and I go inside of the wrangle we have here, then I basically start adding the value that says this thing needs a randomization, so float, and we'll call that float. Actually, is it a float, the random selection? I mean, yeah, we can keep it as a float. Random selection, we'll call it random selection, and we'll give it, wait a second, R and the S, let's make them big, and it should equal the random value between the number of points, so num pt, or pt num, sorry, pt num, multiplied together with the reference. Okay, how do you paste the reference? You go here in any group or in any node where you could specify a group, right click and paste the paste the relative reference, because otherwise you can't paste it, and just put it here in the notepad, right? And now copy it again, and you could delete that group for now. Okay, and go here, and now we could actually paste it. We will fix some of the stuff here and go back inside of here and basically add a semicolon at the end. This should create a random value now. Okay, this still needs more logic to work, but that's a thing we could work on later. And yeah, we just need to learn a couple of new tricks in Vex, and let's learn them. So we've learned a couple of new tricks, how we could, yeah, pretty awesome. So what do you work on, my friend? Let us know you a little bit. I would love to have you on the Discord server later if you like that as well. We have a Discord server called the Generalists, where Generalists just launch, and yeah, a FNAF fan game. Cool. All right. Where's the bread in that? Tell me. What's the bread? So let's see. Okay, so let's get the thing going in here. So we have a float, and we are creating a random, well, it's not a random selection really. This is just a random value. So it's creating a random value out of the point number multiplied with the seed, which is between 0 and 1, which should give us a value that, yeah, basically multiplied between 0 and 1. And good. So what is next here? The next value that we would need to get is a value that takes the length of the list. So it can read through those numbers of our final point search. If I go right there, where is it? FPTS. Come on, FPTS. Where are we here we go. If we click on that, it will go through the length of that list, right, and read it and access each number. Then we want to apply our random value on it, and we'll check that out. All right, so let me read some cool. We are vibing. Just basically get the role. You could choose your role on the Discord server, and if you chose game dev or generalist, you should get all the access to all the channels. And yeah, just put it where you introduce yourself. Like, just introduce yourself. Let us know a little bit more about you. And yeah, it's still a small community, so the engagement is still low, but yeah, it's something we can build together. Anyway, now back to alerting. So we need a value that basically access the list, right? So the length of the list. So we need to we will basically start using new things that we haven't used before. So it will be an integer value because we have integer numbers, and it will be a rand. Which engine do you use, by the way, Ben? Would love to know you a bit more. And I can send the video of some progress. Of course, just share it in your progress and send whatever you like, my friend. There aren't so many rules yet. So integer at rand integer. Let me know if Godot, that's awesome. Oh, my favorite engine. I haven't learned so much into it yet, but it's definitely my favorite engine. You'll get access to the Godot channel as well. We have some Godot developers, but there aren't so many around, so you could post there and, you know, they would have access. They will check your stuff. Anyway, let me know if you have any issues with the Discord, because it's still a work in progress, and if you could access all the channels as well. Okay, so anyway, we're back here. So if we create an integer attribute, call it random integer, or basically, no, wait. This is a bit step too far. Let's go and create our integer value that could read the list, and we will call it read length, because that makes sense for me. Let read length, list length, and pt, what's it called, final point list. Okay, and that one equals, and now without further ado, we need to introduce a new variable. Let's increase the size on here so y'all can see it. This variable will be called len, and this len is basically, it returns the length of an array. And what is our array? Our array right now is the integer list fpts that we want to pull from. So I brackets for list, and so here we go. So you do use I can't send the video. Okay, we'll check that out for you. Okay, let me pause the close. All right, let's check it out. Ben, thank you for sharing. That's smooth. The clicking and everything. Pretty cool. Yeah, and okay. So you're still working on the mechanics, right? Please share more videos and your progress as well as you go. And for the people who are watching the video, we have a Generalists server where you could introduce yourself, and you know, you have your roles. Either you're a 3D artist or 2D artist or generalist or game dev or tech artist, whatever, VFX artist, whatever you prefer, you could put right here. I could see the VFX artist is quite dark. We need to change that name as well. Awesome. We're working. We are getting more people into the community. That is awesome. Do invite the friend that helped you out, my friend, and let's get this community up and running. Okay, so we're back here. Let's get this thing working. So we have given this new way to read arrays. It's called len for length. And now we will give it which length of which attribute we wanted to read. So at final point search and close that, give it a semicolon at the end. Amazing. How's developing in Godot like, my friend? Let us know more about that. Okay, so the next thing is that we need a logic to give us how to say some type of multiplication, some type of calculation that takes our random value in here and multiplies it with the read list length. And this way it should give us a value, basically, which should be the value of the point it had chosen. But that will take some time to get there. All right, so it will be an integer because points are integers, and it will be called our random. Let's call it, let's see. So we have random value, and this integer will be called random number, or random int number. And that random integer number will equal the integer. Let's first start simple. The random value, so it will equal this multiplied by the read list length fpts. It's a bit of a complicated name I put there. It could also be a final list length, whatever. But yeah, it's fine. So we'll multiply the length with the random value. And this should give us one integer number. We need to add more things to this to make it work. I don't understand yet what's the progress there, so I will pause and learn some more. Let's do it step by step, even though if we don't understand it. We have been here said is very hard, but I'm trying at least. Good, like some days ago, and I code in GDScript. Okay, wow, some days ago, and you already have an interesting result. That's pretty good. I think there's a huge way ahead of you, and it's going to be very interesting where this thing can go. Good luck for you for your Godot development, and I wish you a lot of fun. Of course, you can stick around. We're creating some systems and some HDAs. I'm not sure if you checked the other streams before, but we're creating some pretty nice and decent cool stuff. Let me pause let's start the recording again, and let's get this thing to work. So right now, if I put a semicolon at the end of this, we should be getting some type of an attribute called I random integer number, and that one will be random integer number right there. Let's go to where it had calculated for us, and now it's calculating the number 72. It's nothing in the list yet. We're basically just getting the index of the list. I don't yet know what that means. I think it's a bit too much into math for me at the moment, but eventually we'll get there. We all have to learn and start somewhere. Okay, so let's go inside of here and check if we change our maximum search distance, if the number will change. It is changing. You see it right there, 200, 300. That's pretty good. And yeah, the thing is being multiplied by the seed as well, as we established that right there in the beginning with the random value. We said equals the random value between the point numbers and the seed, which is between 0 and 1. And then we created a new integer value. We said it should be read list length fpts, that we should be getting the length, so it should read through the length of our no, I don't know if the length means here the number of numbers, basically. Is that the length, basically? So is it counting 1, 2, 3, 4, 5, etc.? So the lower the number, would that mean the lower the points? And I'm trying here to see the FPTS, not the PTS, but the FPTS. Let's go into FPTS and check how many numbers do we have here. Still a lot. Let's lower it down. All right, now let's check again. We have 1, 2, 3, 4, 5, 6, 7, 8, 9. Now if I change that into an integer or into an attribute, let's call it out. Let's make it an attribute right here. Let's just change here and make an I at, and this should make it an attribute now that we could see. So what did you say? 1, 2, 3, 4, 5, 6, 7, 8, 9. Let's see if it will give us the value 9. We have a lot of problems. Let's just delete that one. Let's just basically control exit and click away, click back again, and get that value. All right, so we have a read list length, and it says 9. It's pretty good. So that is the length. That is what the length is. It's just going and counting the number of the list. Okay, so now we will get this back to what it was right there. The value here is the number of the list, or the components in the list, which we have taken and multiplied with the random value of the point number, and which got multiplied by the seed, and then we multiplied that eventually with the read list length, which is basically just the number. Okay, so let's change the name here. We'll call it list length, and FP, let's call it a final PT point search list length. Good, let's get that and just for our own understanding, so to speak. Put it right there as well. Okay, so what is the next step? We need to force this into an integer. Why? Well, we have the random value, which is a float right there, and it's being multiplied with an integer value, and which will create some weird stuff. So let's force it into an integer and give it the brackets that it needs. So brackets here, bracket here. Good. And then the next step is to have a floor. What is it called? Floor. Right? It's called floor. Let me just check it. Yeah, it's called floor variable. And that floor variable says it returns the largest integer less than or equal to the argument. So it should give us the less or the value that it equals to the argument. So the largest number here out of this will never be output. It will output the lowest number, or the one that is equaling to it, out of this argument. Okay, so let's see what that means. So if our, well, one way to check it out is to upgrade this one to, because I really want to know the random value here. Let's f at random value. It will break everything. Let's just cut this out and say, all right, so where's our random value here? What is the number? 8.8, 0.8, sorry, excuse me. So it will be 0.8, this value, which is been taken from the randomization of the point number multiplied by the seed. So now we know what type of number we're getting from this. Let's return everything to how it was. And so what we're doing is we're taking that 0.8, we're forcing it into an integer, and that integer will be the closest to 1 or to 0. And we're multiplying it with the number 9, and this should output us a random integer number of, here we go, 7. So 7, how did we get to that number? Let's open the calculator. Let's see what we're getting here. Because this is an integer now. It's not a float value anymore. So let's get a calculator. And let's see what happened here. So it's either 0.8. So the actual calculation was 0.8 multiplied by, help me here, FPTS list length, which was 9. And this was transmitted into... first, we got the floor version of this, and then it got transmitted into an integer. So obviously that would be 7. That's good because it got either the equal or the less 2. So now we have 7. This makes sense. So it's forcing it, no matter the float version of it, to go back into an integer. And this is the value we're getting, which is 7. Okay, so what do we do next? Why do we have this random integer number? Well, we needed to establish the chosen point, so to speak. So if we add an integer here and we call it the chosen one, here we go, the chosen one, then 1, good, and the chosen one equals to, and give me a second, the chosen one equals to, let me think. The chosen one. Is this how you say the chosen one, by the way? Is that how you spell it? So the without two E, right? Just one O. EO, what is it now? Jack. Okay, the chosen one, like this. It will be equal to something of the same manner here. So logically we'll have the FPTS as a list, but I don't know how to write it, so I just have to go reference it for now. So what we will do is definitely take the list and attribute, so it will be equals to the list attribute, which is called final point search FPTS. And now we could open a new bracket here, and we could put an entire attribute here inside of this. So it will be so we're taking what we're doing right now. We're taking the list FPTS, and we're accessing its seventh member, or its seventh number. So if I go here, oh my god, it's gonna break. Okay, so let's just take that attribute rand integer number, which is not actually the random integer number. It's the calculation of the random value inside of the FPTS. So yeah, it is a random number, but it's determining the chosen one in somehow. Okay, so let's add the semicolon. Awesome. Click whoa, damn you, Houdini. All right, that's not cool. Okay, life as a tech art, right? So again, so basically we restarted the code from scratch, and we were able to actually follow pretty fast the chosen one, and the chosen one is equal to the integer list of the FPTS final point search. Did I get the FPTS correct on all of them? Yeah. And now we could get the seventh value. So whatever comes out of this will be a number, right? And it will be like we saw before, a 7 in this. I mean, now it will be a bit different, but it will take that number of the coordination of this list. So if it says 7, it will be the 7th number of the FPTS list. So let's do that. Let's put our random int inside of it. And this will be like this. Hopefully it won't break this time. Semicolon, enter, out, inside, good. So let's check our chosen one. And we'll color our chosen one actually. Let's color our chosen one with this similar code. So what we'll do is do this, and we will do a vector value. We'll call chosen one color. The chosen one color, and we'll put it to red, just to see it better. And the chosen one will be red. So the set point attribute to 0 CD. Good. The point is wrong here. Let's get our chosen one. Color that. Boom. It's an integer. So hopefully we'll put it into a point. And yeah. And the range color. No, it will be the chosen one color right there. Good. Let's paste that and then semicolon at the end. Set point attribute. Yeah, that is fine. Let's see if that code make any sense. Set point attribute in the 0, correct. CD, that's the color ID. And instead of point, we have the chosen one. And we have the chosen one color for which set to get from, and then a semicolon. This should work. Let me try. Let me see. Ratanatib Glosh says, bro, I find my job. What do you mean? Let me know what you mean. That chosen one color. What am I missing here? Something in here is not correct. Let's see. We have everything correct inside of here, correct? Set, semicolon, set point attrib. That should be correct too. 0 for geometry, CD. But why is it telling us that the error is right there? All right, now we don't have the error anymore. And here's the red point. Right there. Awesome. So this is the chosen point, basically. And if I change it on the go, and I might save and increment save as well, for not in the temp, but in the actual folder. We'll paste it right there. Here we go. And let's put the number correctly, 4.3, and accept. And now we have our colored points visualized. Let's change our maximum search distance, minimum search. Yeah, it's doing perfect work. Let's eliminate the middle part. Yep, it's pretty good. And let's basically, yeah, play around with it a little bit. Let's make it less. Yeah, you can see it's choosing from it. Okay, now we get what we've done here. I hope it's clear to you all. We've done it twice just so we could understand what's happening. Eventually, my goal is to be able to copy all of these things again and do it from scratch one more time just so I understand. I see that this loop doesn't really do anything, so we'll delete it. Hopefully this won't break it. And yeah, the rest is doing good. Perfect. We can continue later. Oh, okay. So quite the easy task, I would say, going forward is to clean up the code. In which way do I mean? I will show you. So right now, after we basically have created all of this functional code, thankfully, we have created along the way so many attributes because we needed them to view us some things, and we created markers for them. And just for the sake of visualization, we've had them into attributes. So what are we gonna do now? We're gonna basically, what's the opposite of promote? What's the word opposite of promote? Opposite of promote. Let's see. It is prevent, hinder, inhibit, discourage, prohibit. All right, I don't know. Unpromote. Yeah, we will put them back to just normal variables, so we have less of a mess here. Okay, so let's pull the notes and just paste everything in here. That is our old code. Save that thing. Probably don't save it. It's fine. Okay, so let's see. One way to copy or to basically have a backup, just copy the same wrangle and paste it there and just have it there. Give it a different color. Maybe have a color for backup. I have black. And yeah, let's keep going from here. We've created all these bananas here. Okay, and now we will basically go one by one and delete it. And so let's go one by one, see which attribute we don't need to be an attribute, and just have it as just a normal variable. So first one are those two lists. We don't need them to be attributes because we're not going to do anything with them. So the way to do it is you just basically, okay, you copy those two brackets, cut them out, add an int, remove the add, and add those here. Same thing here. Delete, int, good, and one there. Okay, so now we have created, okay, also remove the add, and now we created those two. Now we need to remove them inside of the code in order for it to work. Let's follow it one by one. So same here. It will be just PTS mentioned like this. Where is it mentioned next? So now we're going through it one line after the other. Distance also we don't need to be an attribute, but we'll go through it later. For now we're focusing on those two. One is the PTS, which is not mentioned after this one, it seems. If we see it again, we'll do it. So right now let's focus on the FPTS. So it's just called FPTS everywhere instead of I list FPTS, which is going to be a normal FPTS. Same here. Just going to be an FPTS, will be mentioned again. And this random integer doesn't need to be one as well. So let's go now to the next one. Float dist, fine. It doesn't need to be an attribute. Aim, same deal. Vector and add away, vector and add away, and yeah, it keeps going like that. alignment, float, alignment. We don't need that as an attribute. So same deal here with those aims. They are just aim A and aim B. And the distance is just dist. And alignment is just alignment. It's just alignment. And here we have an FPTS. What do we do with it? We delete it and back to FPTS. Just like that. For each integer point FPTS range. All right, yeah, this is all good for now. Where is our next attribute? Pit num, that is an actual attribute from Houdini itself. And then this random integer, we need it to be just a normal integer. Int random int, good. I, the chosen one, keep that. I random, nah, just keep it normal. Vector, the chosen one, I, the chosen one. Okay, let's see. Put this up, click away, click back again, and we should have the same settings, basically the same colors. Yeah, let's view it as well. Here we go. We have the red, we have the green, everything is working pretty well. Is it clean? Let's check it out. PPP, position, CD, CD, CD for the color ID, N, normal, the chosen ones, basically the chosen one or the chosen ones, whatever works. And then we have a group spawn position. Yeah, that one is fine. We're going to keep it as well. Or do we not need it? Let's check. Group, where append is. Append. And then where did we group things up? I remember putting them append here. Right after the append, we should have had group. Let's see. Where did we create the group? And why is it not here anymore? Let's see, integer points. I'm just checking his code. Minimum alignment, good. Append final points. Yeah, there are no groups anymore. We probably removed that. Let me check on the actual file, the final file here. If I go into the wrangle, remap growth length, which one is it called here? Not sure which wrangle it would be. Convert growth length. Let's see where clean, alt clean, boom boom, inside of a switch, good growth, merge spine, and here we have a remap growth line. I think could be this one now. Okay, is it this one? Nah. Where is our wrangle? Wrangle. Yeah, I can't find it. Can't seem to find it. Might be this one here. Is it this one here? Okay, doesn't matter for now. Probably this one. Convert. Nah, also not. Yeah, it's maybe, yeah, in the generate vines. Probably it's going inside of here. To create more stuff. Select spawn. That's the first one. Let's go to the second one. Attribute transfer. Where is it? Where is it? The wrangle. Where's the second wrangle? Damn it. Yeah, group, attribute, normal, and yeah, and find endpoints. That's the one. Let's see if they have grouping on it. So we'll check that out. Control F. Is that possible? I'm not sure. All right, so let's see if they have. Here it is. Group. Yeah, let's search for a group. Nothing in the group. Okay, that's fine. I think the group was made from, yeah, from before, basically. That's fine. Good for now. We've cleaned the code. Now we only have the color, and we have the chosen one. Awesome. Yeah, let's continue. One thing I wanted to do is increase the threshold in this one to see more points. So here we go. Threshold, and now we see that in our line here we have different points that are selecting, that are having, you know, the range, and they have red spots that would select. This will create our branches, basically. And if I increase that even more, we will have the thing spread everywhere. Now it looks like rot. We don't want that. Okay, so let's keep it pretty low, I would say. Let's keep it on 0. Yeah, that's fine. All right, so save. Don't forget to save your file. All right, so what we'll do is we will pause. Hi, Alex. Thanks for dropping by every day, man. Here we go, people. Now we'll promote some stuff. I know you might be confused of this. Nothing to worry about. We split the view, right click, type properties, and now we can promote some stuff. Okay, quite excited for that. Let's go with the split bias first of all from our original wrangle from before that controls the randomized selection of the points. And that one, well, let me view it first and yeah, click on it and space G. And what it's doing is basically selecting the points that will extend, that will basically do the spread. So the naming here is pretty wrong, I would say. Controlled randomized spread or split. Spread, split, same thing. Okay, so split bias, we need that. Alt, middle click, boom, inside there. Now our default value is this. We could have changed it, honestly, but for now, we'll keep it like it is. Interpolation, linear, for now, everything stays the same. Then the next stop will be our threshold. It's very important. We'll keep it low, so when we load it into Unreal, it doesn't go insane. Seed one, fine, that can stay like it is as a default value. The next thing will be inside of the code we just wrote. Right there, we have a minimum search distance. We need that. Let's keep it on this value. That's fine. The maximum, yeah, it could stay like this. Although, let's make it into something like 0.5. Let's view it. Here we are. That's a lot of maximum search. Yeah. All right. So 0.2. This would work. Yeah, this looks good. And so yeah, let's add minimum search distance. Boom. Maximum search distance. Amazing. Then the spread itself, I wouldn't like it to go all the way to 0. So would like it to be somewhere like here in the middle. And this one would like it to have, well, wait a second, which one is which now? So this is full. Yeah, I want the middle part to have less. I don't want it to grow on itself. I just don't want it to. You can have it to grow on itself. That's fine. Let's Alt and middle click this one, Alt middle click this one. And now we have all this control. And we'll put them all in folder, call it, no, not geometry data. We'll put a folder, call that folder spread control, spreads and search. Spread and search controls. All right. Put all those puppies inside and drag and drop there. That's good. And yeah, let's check our, I don't want it to tab, I just want it to be a simple folder. Apply, accept. And now when we click on our thingy, we have spread and search controls. We have the split bias and its options, and we have threshold of the search. Threshold of, we need to rename those things, honestly, for them to make more sense. Back. And yeah, let's control those. Let's type properties. All right, so threshold, I don't know. Let's call this threshold for threshold how can I call this? Threshold of search, not search, threshold of spread. All right, and here threshold of spread. Seed just allows different seeds. That's fine. Let's put that thing all the way to the bottom. And we can't for some reason. It's funny. Okay. Minimum search distance. That's fine. Maximum search distance and minimum alignment. Maximum alignment. Fine. They'll figure it out. Apply. Accept. Just feel like the threshold need to be threshold of spread. Let's make this smaller. Let's make this smaller. Let's, yeah, fine. This is a good setup for now. All right. And now put this thing back. Good. Save. And just looking into something, but he doesn't seem to cover it, but I don't think it's quite hard. Yeah, we just need to change this thing to make it more readable. Maybe 1 point here. Let's delete this point here. How do I delete it? Go on it, delete. Delete selected points, delete. Doesn't want to be deleted. Huh. Well, what is stopping it? Maybe the reference from the DGA, from the HDA, sorry. Let's go here. All right, can we change this? Yeah, we could change this one. All right, how can I change its default value? Type properties, node, and go into the parameters, write this one, go to the import action. Doesn't seem to have a default value, it's fine though. Let's have constant. Now wait, let's have a bizarre. Nah, let's wait. Let's do hermite. Where is it called? Which one was it? Yeah, this one definitely. Or this one. Still. B-spline? Yeah, B-spline, definitely. Okay, this I like this one because it does this growth. All right, so now we'll check inside of here maybe and get a space G. And now the whole point is that we could control where this is growing if we switch it like that. But I don't like that this thing is not. Let's try the other thing. Yeah, this one. And yeah, you could see that the spread is being chosen to where this is located. So that's a pretty nice way to control it, so to speak. So yeah, let's keep it like this. Save the damn thing and let's pause. So this is gonna be a bit, that's gonna be interesting. So let's see, I watched a lot in the video. I think 5 minutes in. We're in the next video, by the way. So we will try to do some of the things that have been told to us and taught to us by understanding the actual concept and not by just following one by one. Okay, so far, but right after this point, so right after the wrangle, we will add a subnetwork. We will call it as we have our name. So subnetwork right there. We'll have the name gen because we'll start generating our connections, and so we'll call it generating connect connection curves. Okay, curves. Okay, and we'll be purple. Will be right there. And so now we'll start connecting the points that we are calculating. If I may, I think we lost some because of the threshold. Let's see, threshold, let's go right there. And the threshold is there. Let's go with 0.3. Now we'll have more points to work with, like right there, as you can see. And the thing is in the middle, so we could keep it right down there, so we have a better result, in my opinion. So yeah, these are our points, and now we will communicate a way to spread the points. I just find it interesting that it only picked on the right side. So let's go with the seed, change the seed a little bit. Yeah, now it's going on the right and the left side. Okay, so yeah, let's go with this. And yeah, we'll put that thing inside of here. And we'll start cleaning some things up. First cleaning process will be a blast, and the blast will be a quite interesting blast. It will be a bit different than before, because what we will reference here is the chosen one value. So if I add a null here, I'll say we'll call it in calculation of potential points or chosen points, and good, this will be green because it's a calc. And so if I view this one, it has the chosen one as an actual attribute, and we will access these now in the blast. So what we do is in the group, do we go with the spawn points or do we go with trying to understand? just let me go a little bit backwards in the video and just it's called endpoints, and I think the endpoints on his end. Okay, so let's go with the attribute. We can add an attribute here, so we'll call it add and the same name, same spelling with the 1 chosen and 1, and now we say equal 0, which would do this type of effect. If we look at it inside of here, it would, why is it not doing it? Let me check. I'll be right back. Okay, so let's go back. We need to set it up to points in order for it to work. And here we have our points that had been chosen for us. And if I reference it as a template to this one, yeah. Okay, let's view this one. And yeah, but okay, let me hide this. We have the chosen points here. So why is it taking this one? I don't understand what we've done here because we added 0. I think we're just taking the original threshold points. Let's reference that actually. The original reference points from the threshold that were here after the adds, and so right there, yeah, these are the points. Okay, so that is what we've done inside of here. I just don't get the expression, so we still need to work on that to understand this, what it means. In the course they say the following. Wait, let me check it out. So we're deleting everything that does not have an endpoint value. So for example, do the primitives have an endpoint value? Incorrect. Does the whatever have an endpoint value? No, only the points have endpoint value, and that is shown when we check it here. This has all endpoint value, right? It has a 5, 6, 11. So if I check it inside of here again, where you're saying delete everything that has the input, the chosen one value. Or sorry for saying endpoint. That's what he says in the course. So let's go back again and try to explain this again. When we said in the blast, give me the chosen point value of the, give me the chosen one, give me the 0 value when, give me the chosen point attribute when it's 0. So it's pulling everything that has the chosen point value, the chosen one value 0, and it's deleting it. And those who do are staying here. So these points, basically 7, 0, 6, etc. So if I go here, we see that most of the shapes and primitives and all the other values have 0. So it's deleting everything that is 0. And if I flip that selection, it's actually a pretty cool way. If I flip it, it will delete everything but. But now we're basically selecting the points, the original points that generate the search, basically. That's pretty cool. Okay, so what is next? What comes right after that part? Well, we will need a for each point, not for each connection, not for each piece, not for each primitive point. For each point, we'll hook it up right there. And now we should have the same number of points. Here we have 8 points, and here we have 8 points. Perfect. Let's see what else we could do. We'll basically add a group, and that group will be called starts. So put it here. So it will be a point group, and it will be called starts. And it will define the starting points from the points here, right? Because these are our original points. So it's starts. That's what it's called. Okay, what comes next is that we need the points that we have searched for. So the chosen one points. And one way to do that is to go through a group transfer right from the null. So let's do this here, and let's add a group transfer. And now I'm going a bit off I'm just going off memory and trying to understand the logic behind it. Let's do a Shift S. And so we will transfer from, right, to transfer group 2. Yeah, and this is the from. So what we will transfer is basically our, so we will delete this, and go with the point groups and add the starts. So now this value has the starts, and now we could do more stuff with it. Let's put it next to it. And now next to that, we will do the most important part, which is find shortest path, which will find the path from the starts until the chosen points. So let's see how that's done. So shortest, like this, find shortest path, and we will hook our group transfer. And let's put the stuff here a bit down so we have more space. So yeah, we have our find shortest path. It will, we will define its starting point and end point right there. The end point will be a bit more complicated, but the start point will be definitely the spawn points, which makes sense because that will be where we will start. Oh no, wait a second. We could also now let's go with the starts. I'm trying to think. These are both the same. And it will end in the, let me review just so I completely understand. We have the chosen one inside of this group. We can hover over it with the middle mouse button. Yeah, we do have the chosen one. So basically we need the chosen one. And we've learned before that we could add the spare input. So let's add the spare input right there. And that spare input will be our group right there. And basically, now we referenced it inside of here without connecting it anywhere. And so our start point will be the starts, which also could be the spawn points, also the same. And then our end points will be now an expression. So we'll start with this, which is over the tab button. And we will start with point because we will work with a point group, and we will call now the same way we did before. And that is, okay, so string surface node, that is which node, which input of the node that is. It's a spare input, so it's a -1. Spare input 1, -1, spare input 2, -2, spare input 3, -3, etc. Input 1, 1, input 2, 2, or 0 for the same actual node. So for now it's -1. Float point number, it's number 0 because we are inside of a loop, and the first point number is 0. String attribute, which will be the, let me think, it will be which value we will use, and it will be our the chosen one attribute. So yeah, string attribute, and float index will be 0. Okay, so let's go -1, and the next one will be the float number, point number, good. Then the next one will be string attribute, which will be the chosen, and we have to put it between brackets, I think. The chosen one, and the next value will be 0 for the index, a closed thing. I don't think we need to close it with, yeah, I think this should be fine. Let's view what we've done. We need some settings here to be set. Maybe let's add a semicolon just in case. Yeah, that's not gonna work. Okay, we have a point, it's an expression. We're still getting errors. I think we need to change a couple of things here, from each start to any end, from any start to any end, from each start to each end, and loading. Oh, we probably need to blast a couple of things first. Hi, Lost Artist, how's it going? I've mistaken here by not choosing the right threshold for the transfer group. Let's go with 0.001, which will make it more accurate to the group transfer. And if I take it, you're gonna see it like, this is a pretty cool effect, by the way. we accidentally created a pretty cool effect that starts from a point. But yeah, this thing, if it is on 0.001, as such, it will give us a creation of the shortest path between the point and the other point. And if we only view that one, all right, now we can't see it, but if we find the shortest path between them, here it is, and it will look like that. And if I view now, if I hook this up inside of here, and I view the each point, and we see that it had created a network of of connections. They are not yet hooked on the column. We still need to make them fit on the column, but we've done that before. And yeah, I bet there are some couple of more stuff or steps to do. Right after that, let's review what we've done so far. We have taken our output from the calculation, so from the wrangle itself. We have cleaned the points by getting a blast that blasts all the points numbers that have the chosen one value of 0. We've done that here with adding the add attribute. The chosen one equals 0, and it had deleted all the points that start with 0. Awesome. Then we've added a for each point loop that started with the grouping of those points, and we call them the starts. And then we took another input or output from the wrangle. We put it into a group transfer to basically transfer our starts group into this input. And we've added a threshold to it, so it focuses only on them, which had helped us eventually with the find shortest path when we have added the start point and the chosen one point here. Because this one is hooked right there, it's doing the surface geometry, and the surface geometry had been transferred or had been gotten manipulated with the actual threshold, and this had got us the opportunity to create the shortest path between those 2 points. Then eventually it goes into the for each point, and it will do the calculations for all of them. And this is all dynamic and happening. It's cooking in a real time. Okay, let's see. Let's pause. So basically now if we test this thing in our HDA, we'll see some mistakes, and we need to fix those. So the number one mistake is if I merge now, merge that, and let's get the thing inside of here and that one inside of here. We'll see how small the points are in comparison to the thing. So we need the match size basically to work. Okay, so let's get that thing working. Let's go inside of here. Let's expand this one and get the match size. So match size will be right before the output itself. Match size, and we'll get our X form in here. Let's see. A scale to fit definitely, and yeah, let's get our restore X form. I think that is the proper way to do it. How was it before? Wait, how was this before this? Yeah, something is not completely working here. Let me check one thing here in the match size. We'll go a bit in the tutorial. We'll be right with you. I think we missed something. Let's go back. A lot of sense. I completely forgot it, so let's do it. This blast is not needed anymore, I think, so let's delete it. So for the match size, like we've done before, we need transfer attributes. So let's do that. Transfer attribute. The screen is super bright. Give me a second. Okay, so transfer attributes, and we will get our attribute before in the wrangle. So from, and we'll put it to, and then this thing is gonna go inside of the match side, the size, and we'll get our detail attribute because we need our X form. And in here, we need our X form. Exactly, restore our X form. Awesome, good. All right, so let's see if that worked, honestly. Match size. Where the heck is that thing going? Wait a second. Let me try to understand what's happening. And yeah, so now we have matched the size. And Sproul asks if we're following the tutorial. Absolutely, we are following DoubleJump's Academy, Houdini for Games in Unreal Engine's workshop. The link is below in the description, and we have documented our progress so far on YouTube. Basically made the supercuts of those streams, and yeah, what an 8-hour stream will be a 3 hours progress documentation on YouTube, starting from 5 weeks ago with no knowledge of Houdini whatsoever, and here we are today. If you haven't followed us on Twitch, it will be a huge help if you do. But I see that you have the crown. I think that means you're following or something. Yeah, but for now, let's go back and get back into it. So the match size have actually worked here, I suppose. I think it might need to restore the transform, but at the same time, where is it restoring it? Damn. Oh, it's making it big again. But do we need that? I don't think we need that. Let's check again. Space G. We'll check what his settings were in the course. So since you're asking about those stuff, I'll also put it in the recording. That's fine. Okay, so no, definitely. I appreciate your questions. Would you say this workshop is more for HDA beginners? So here's what happened. I have never worked with HDAs before. I was always interested in it because I've seen a lot of nice generation tools out there for Unreal, and I was always wondering how the heck was that done. So the decision for me was that I started learning Houdini 6 weeks ago in preparation to attend the workshop, because I basically just paid for it, even though it says it's an intermediate. I just wanted to throw myself into something that is harder, and I thought it would be hell to follow, right? So I started with the first week where I like I remember 4 days where I attended like a YouTube course for free about Houdini, and then I jumped right in and I was able to read the user interface. I was able to follow every step of the way basically, and without any troubles, even though I've never touched Houdini before. So that is why I say this course is worth it, because even for beginners who like me, who has just started 5 days ago, I was able to follow. But that's just my experience. I could just tell you my experience. For you, it could be different. I don't know. But I've never felt this encouraged to ask questions inside of the DoubleJump Academy's Discord. And I was always able to drop by either the same channel from the course or drop by the Houdini chat and just ask a question, basically. So yeah, that was pretty cool. I was able to do that. And I think there's like a couple of content for free if you want to check that out from them, if you use the link I sent you. And you should be able to also get a discount from the link that I sent you. I'm not sure if you're going to purchase. If you ever purchase, just make sure that it's the link, because there's a discount with that link. If there's not, let me know, because I can fix it. Okay, so let's pause. Let's record some of that. Let's document it. Let's go restore transform right there. And basically go a step backwards inside of here. Now we can merge and check our points if they are translating right there. Let's check it out. And let's go with space G. Yeah, good. Yeah, here we go. They are spreading, definitely. That's good. So we have the match size configured properly. Let's save our process and make an incremental save. Shift S, 4.4. Good. Let's add a sweep operation just to see it. And in there, let's not touch it before, because I would like to... Let's see, do we do it before the attribute transfer or after? Let's do it before. Let's see what we can do. Ragwesh Ratter says go. Yo, no, not go, but yo. We'll read the comments in a second. Let me just try to get this thing. Stay with me. Sweep. So that's pretty sweet. Let's get some sweep on those things. First, we need a round 2. Let's view what we're doing first. Okay, they're small again, so we're gonna go back in here. We're gonna do, I don't know, 4 radius will go down. We'll disable this one, stretch, so it doesn't stretch. Let's make it smaller even, so 0.02, 0.04, maybe 5. Yeah, this looks good. So this will be our veins, so to speak. Yeah, this is good. Let's save. Let's not save yet. Let's go into, let's see, which one do, let's do it inside of the clean, honestly, right there. Not the clean, the generation. Should be fine. Okay, go backwards and view the whole thing again with a space G. Here we go. Yeah, we're getting some results. Yeah, it's spawning some nice sweeps. It's connecting it and it's getting the same result. We can, however, play with the sweep furthermore with making them space G again, making them more round, like as such. Make them a bit bigger or smaller, whatever. Yeah, and then look at them again with the merge, space G or space F, and here we go. Yeah, we're getting somewhere. We still need some noise on this thing. It's looking pretty good. And yeah, let's pause. Okay, people. I just have noticed that in the workshop, Grayson adds an orient along curve inside of the loop. So we will see what that affects if we actually add it. I'm not sure what it could affect, but the trajectory could help here. Let's see. Merge. I mean, did it do anything? Not really, right? Ah, interesting. Let's see. Okay, so yeah, I forgot to answer one of you people. I'm gonna make sure to answer. So we'll work on our mesh now and make it merge not here, but inside of the HDA itself. Makes sense. So let's do that. Let's expand this further. I'll read your comments in a second. Allow me to just work on this thing. Proceed a little bit further. So we'll add an object merge. We worked with object merges before. That's awesome. So let's add tab object merge. Here we go. And inside of this object merge, we'll get the in mesh. And this will be called mesh. Good. And we will put that thingy right on the bottom. Before the match size, we will just basically merge some stuff. We'll merge our original mesh with, here we go, with the attribute transfer, and this both will go into the match size. And this will look something like this. This doesn't work. Trying to understand why that doesn't work. Let's see. I think we might need it to go out. All right, give me a second. I realize that I've done my structure a bit differently. So what we'll do, that merge and that object will go somewhere else. So Control X them, put the thing here. And we will do the merge right there. Fine, let's do it. Good. Let's take the mesh and merge it with the match size. And then it goes here, right? This should make it work. Yeah, it's better. Okay, yeah, this works. And press space G. No, space G here. And this should, yeah, put us back inside of here. And now we have the actual mesh that shows from this level. That's amazing. And yeah, let's see what we could do from this point on. All right, so we created that. Let's see what the next steps are. I will follow and y'all gonna stay with me. And yeah, only we will get this. And absolutely, let's basically take the generation of the sweep before and put it in its own subnetwork, because I know that thing is going to be some work later. So let's make a new subnetwork, so to speak. Okay, subnetwork, here we go. We'll call this one generate sweep, gen sweep, because I know sweep can get really complicated later on. We'll keep this here. For now, we will figure out where the generation sweep will be at. Probably Here is a good spot for them, right before they merge completely. On our path, yes, definitely. Learning, would love to learn Python. We're learning a bit of Python, like today's stream. In the beginning, we've been learning Vex, which is basically type of Python. But definitely Python for now is interesting. We'll probably go into C# or blueprinting in Unreal because it's quite interesting with the tools that you can make with blueprinting. So those are on my scope, Python and blueprinting. And then eventually C# if we ever get there. You know, let's see. Tech art is definitely a place that is that allows you to have a lot of skills. And the more you have, the better, basically. So we'll put our sweep operations right there. And this will allow us now to sweep our... where is it? Why is it not going? What are we sweeping and where is it? Space G? Oh, dude, where are we? We lost track. Let's go inside of the match size. Yeah, okay, this thing is a curve. It's going inside of the... Does it have to be before, maybe? Yeah, this makes sense. Okay, that's fine for me. So the next step is to get our main curve, hook it inside of here. And let's see how that will work. So let's get our main curve that is generated inside of here. It got cleaned, then it got out, and then inside of the array. So let's get that. Let's call it, let's bring in our null, and let's call this array, oh, how to say, you know, when you like put things on something, it's how to say, it's fitting, molding, let's just call it like this. We'll get it inside of here and one more inside of here, and then this, yeah, let's get that null and call it out ray molding. I don't know if that's a word, honestly. Do you want me to share good Python courses for beginners? Yes, please. Everything you could share with the people in the Discord will be a huge help for everybody, and so that they will be also encouraged to share their courses. So definitely go share all the stuff you have, share them. I have no rules for now other than make sure the link is... Also, I'm not sure if you can share, so because before it happened that someone couldn't share a link, but just let me know if something doesn't work, honestly. Okay, anyway, back here. Let's go and make this operation. All right, it's fine for now. Let's add a object merge, and we'll get that out ray molding inside of that object. We'll call it the same. And let's take that thingy down to here. Let's control exit maybe inside of here. Oh, no, sorry. Absolutely not here, but here. And now we'll run it into a sweep as well. Let's merge them before. So we'll add a merge right there. We will paste this and give it another hierarchy because now it's beneath a subnetwork. Let's merge this into this and this into this, and then it should give us the actual result of that sweep. I don't know where this is happening right now, but it is happening. That's pretty good. Yeah, that is our... Yeah, that's the curve. Looks pretty neat. Let's bring our queue, our column, so to speak, here and see if it is matching on it, if it's molding on it. Yeah, that's awesome. It's pretty good. Yeah, for now, that's the start. We'll need some noise on those so they can create something like this. Like this one, it's for sure has some noise and different values. So yeah, I'm excited to add that. I think we'll do it in the next video as we complete this one. Not the stream, but the video. And yeah, what does that emoji mean? I don't understand. Are you waiting for me or... Let me know. I don't read emojis. I can't. Or emotes. Sorry emotes. I mean emotes. Sorry, Twitch. I hope you can forgive me. Let's pause. Let's play with it a little bit. Let's have some fun. One of the main thing for you, or at least from what I learned from Grayson, is one of the main things that you should show that you had fun on your portfolio or on the tool that you're creating. We're definitely having fun, aren't we now? Let's add a color. And let's color those. The color red, maybe. That should give them a color. Yeah, here we go. Let's change the color to something like the stream color, which is purple. Good. And let's go back. Here we have the purple color. And now what we will do is play with it a little bit. What I mean with it, I mean the HDA itself that we created. So if I split this view here, oh my god, my mustache is everywhere. And let's play with this thing. Let's play with the parameters that we created, especially this one. Let's choose either a hill from here. So it will only grow in the middle, as you can see. Or we could choose linear round. What's a round? That's funny. So it will only grow at the end, which it's not doing because of our settings that we have. Let's do, let's keep it on a hill. Let's maybe flip it basically in here. And now it will do beginning and the end. And now we can actually increase our threshold of spread to something bigger, and we'll see more spreading happening. What we could also do is have different seeds and increase our maximum search distance, which will allow them to spread ahead even more. And you know what we could do? Add some of the pig head here to test it. So hook that in here. Now wait for it and space G that thing. Yeah, here we go. The curve still needs to be drawn again, but yeah, that's the type of stuff we're dealing with right now. We can redraw it. So let's clear it and enter in the viewport and zoom out. Oh, where is it getting its information from? No, dude. Give me the pig head. Yeah, here we go. Space G and draw some stuff. Let's draw it like this. Look at that thing, man. Look at that spread of that infection, dude. Hell yeah. That's pretty cool. I think once we add another curve, it will break completely. Oh, it's continuing where it left off. Interesting. I didn't think it would work, honestly. But it is. That's pretty neat. But yeah, we have the ability to change things, which is awesome. We can see that it's not spreading in the middle, but we could do is add this here, add another one. Yeah, make this one high again. And add another one here. It will load now. Yeah, here we go. One low and one high. So we have spread, no spread, spread, so to speak. Spread, no spread, spread, spread. Again, good. That looks amazing. Yeah, we've been working on this thing with the Vex and everything. So yeah, it's looking pretty good. We just need to edit the things to make it work a little better. Super good until now. I'm having a lot of fun here. Would like to add like different models as well, different 3D models just to check it out. But this is looking awesome for now. Let's save and let's play with it furthermore, add more settings and keep this thing going, everybody. One reason this thing is taking a long time to load as we're playing with it is because there's a lot of polygons in here. All right, so how to reduce that? Let's go to our operation that cleans the mesh right there. And in one of those meshes, let's do, yeah, this is a 0.01 that will make a lot of freaking points on it. So here we go. Boom, that's too much. What we need is 0.025 maybe. Yeah, this will give us less to work with, and that will make them 5,000 points. This will be a bit less to calculate from. This looks good. Let's go on an HDA level. Let's hit on W. I'll read your messages in a second. Give me a minute. Let's go to threshold of spread. And this one basically will allow more things, more spreading. Okay, give me a break. We were working on the mesh the poly count basically of the mesh. So we made it less generally. And what we could do is definitely a poly reduce. I think it's called poly reduce. Yeah, at the end before the output here. That would allow us to have, this is the percentage. Let's see, that's fine, keep it on 100, but is this the one? Nope. Is this the one? Nope. How many polys are we working with? Yeah, okay, so that's fine. Let's do that. Let's now go back in here and play a little bit with our tool and go with the threshold of spread. Yeah, things are going a bit faster now. Let's go to our magnitude, to our alignment, and play with that a little bit. I feel like there's a bit of too much threshold happening. So that is fine, around good. Here, let's do a 1, 2, 3. This is too much. Let's see what else we could do to make this thing look better. Minimum search distance, maybe a bit bigger, and bigger search distance. Generally, yeah, will give us longer branches. And if I increase that minimum to minimum, let's increase the max to minimum, to a bit less, not minimum. Yeah, this looks pretty nice. Yeah, it's random, it's generated, it's procedural. Let's see what else we could do to make this look a little bit better. So one of the things that I have missed and haven't been able to focus on is the following. So let's go, and we'll have a lunch break just in a bit. So what I will do, definitely go into our clean, the clean mesh, and go to our VDB. For now, we have it into something low, like 0.25. This has destroyed the shape of the pig. So let's go with 0.01. This will keep the mouth of the pig, as you can see, a bit better. But we have a lot of polygons. So we have around 38,000. And now if I go into the poly points, it is not reducing anything because we still need to enable this one, continue reducing within quality tolerance, which should reduce the mesh while keeping its general shape, just like that. That's a cool trick to have in your arsenal. Good. Now the generation will be a bit different. Let's remove this. Yeah, you see we have less jaggedy lines. Let's go into the sweep. I would like the radius of that to be a bit less. It's too big right now. 0.05. Fine. Save. Go back. Yeah, it's fine. Let's go here. Yeah, this looks way better now. Here you go. Yeah, we got less points and we still contain the shape. All right, so let's get our maximum distance upwards, which should not break anything because we have reasonable reasonable amount of poly count. Yeah, we could make this go crazy with the poly search, so it could go anywhere, everywhere it wants. We can increase the threshold to have more stuff, splitting, and now the thing is completely destroyed. Yes, this is awesome, guys. We've created this from scratch. Yeah, this looks pretty disgusting, actually. So what I will do is go and eat because I'm losing a lot of energy. So yeah, we'll be right back with y'all. I will play one of the prior videos in the meantime as I go and start cooking. And we'll eat. It will take around 45 minutes. If you're wondering how we came around here, we'll play the video from yesterday, day 25, the supercut of it, and let's do just the last 45 minutes so we don't do too much and we are not super boring for a while. Actually, should I make it's fine, should be okay. All right, let's put that thing here and let's put it on full screen. Let's give y'all the opportunity to have a break, and so we'll enable be right back lunch break right there. We'll put it over my face. We'll close it. It's fine to not see my face twice, I guess. Let's put it right there, man. Here's fine. Be right back, lunch. It's super small. Anyway, this should communicate the idea, basically. All right, the next one will be here. Be right back, lunch. It's super big in here, so let's reduce that one. Oh wait, we're not controlling the actual one. All right, so this is be right back, lunch break, exactly. And let's have it play the sound from the computer. Oh, we have everything on recording. Well, I have to edit the follow. We had a lunch break. It took a bit longer than usual, so it doesn't matter. Now let's work on those weird artifacts here. Quite simple. We've done this before. It's not like it's a secret, so we'll go inside. And let's go inside of our generation, or the generation of the connection operation. Sorry, I think that's more of an operation, honestly. Yeah, it doesn't generate any meshes. So let me put it in consideration. Let's keep gen for now. And let's go look into this. What does it do? It goes in calculation of the chosen points. Then it goes into, yeah, we blast some things. Then we took the ends and we connected them together with find shortest path. And now we have orient along curve. And what we'll do eventually is take this down. And I'll start adding more stuff. One of the main things that we want to add is we'll press tab and then we will add resample. I just noticed that we have the effect as well on the vertical stream. So yeah, now we're good. So here we go. Resample. Good. This allows us now to resample all the work. Funny enough, a TikTok app had just completely evaporated. I don't know where it is. Anyway, but can I choose it from here? It's also not available. Funny. I guess it's just not working anymore. Let's record again. Resample is right there. So if I check our point number and count, we should be able... So if I increase that number here, we'll get less connected results. If I keep it on 0, we will get the same jaggedy jag stuff that we might need. So let's go with 0.1. or 0.2. This is good. Let's add a curve to it. So curvy. Let's go. Right here. Sorry, not curve, but oh no, smooth. Let's make it smooth. So we make it curvy. Right. So here we add the smooth operation. And this should allow us now to have smoother lines. So if I go in the resample again, I up that one to 0.05. Which should basically give us more or less things to work with. The less it is, the more performance friendly it will be, but this should work fine here. I really like that effect. Let's see if it works. Let's see if this works for us, and if we should go between 3 or 0.02. Basically, the smoothing is probably doing too much work. Let's see which result of those will give us the lines that we wish for. I think the higher we go with this value, the more details we get. Strength here will determine how smooth it will be. Let's see. I really like that, but maybe something of 8 or 5 could do the job here. And it looked like this before. Let's see if we should put that actually before. Let's see, so smooth and resample, let's put those here. Yeah, that's much better. Okay, here we go. So we have a resample that is reducing our points, hopefully, or just at least giving them an equal amount. Pretty good. We created a smooth operation on the thing, so we lose those jaggedy lines. And let's see. Yes, I posted the Titan tutorial. Is that tutorial? I'm not sure if it was a tutorial, but yeah, thanks for letting me know. Okay, so this thing now is really smooth. So what we will do is probably try to reduce our settings here a little bit. We'll make our max. Oh yeah, all right. So this one will be a bit closer to this one. We'll go here, same. The search, the maximum search should chill a little bit. Right now it's searching way too far. This looks pretty well. The threshold needs to chill as well. Okay, so this is good. However, I feel like it needs a bit less smoothing on it. So that's just my personal feeling. So let's see. We're gonna go all the way into our generation here. It's actually an operation. It's less of a generation. It's more of an operation. Let's go to our smooth and let's reduce that. So this is bad. This is better. Can we go into a 10 here? No. Okay, here you go. That's what we need. We need those lines that are quite, yeah, maybe not so much, but like a bit smoother. This is, I really like that result. Maybe we need more or less resample. So here, or maybe even less, like 1.5. Let's try that one. So give us more points to work with, which will allow us to smoothen it easier. Okay, let's check that result out. Go all the way to the HDA itself and zoom out. Take the thing here out and it should look like this. And now if I generate more points, yeah, here we go. Let's get the threshold a little bit more upwards. Yeah, and this should generate now every time. Let's take the minimum search distance as well, bigger. And this lower, so it goes crazy. It grows all over each other. And now let's draw another curve. So we clear those curves right here and we draw another one. I love that it keeps consistent with going upwards. It's pretty neat. Let's view it again. Yeah, that's pretty cool. Awesome. Yeah, this is an issue we could fix, I assume. There's still much more to do. I think we're getting that result due to our VDB clean mesh. So first of all, that's an operation, I feel, more like than an actual generation. So keep it yellow. Let's go all the way up to our clean mesh and let's check our poly reduce space G inside. Yeah, that's pretty much what's happening. Let's see what we could do about that though. Maybe we can up the value of the VDB here. And by up, I mean lower it, 0.05. Yeah, this is more accurate. Let's see if that would keep its shape after the conversion. Let's see how that will work after all the work. Let's see here. And is it better? Wait, let's see. Yeah, it is better, but I feel like that's also due to the smoothing. So part of the problem is here. Part of the other one was here. I'll check it out. I'll check your comments in a second, my friend. Let's see. We will go to, let's see here. Now let's go inside of here. Let's go inside of the generation sweep. Let's see what we could do. Let's get into here. And this will be the nose, I believe. Yeah, this is the nose, correct? So let's basically work on that. Where is it? Is it though? Oh, wait. It's the operation. I completely forgot. Okay, it doesn't matter. So let's take the smooth and check what we're doing here wrong. We need more value of this, it seems. Less of this. Yeah, but nothing is taking it outside of it though. So let's see what we could do. Resample, maybe something lower. Like 0.011. Would this help now with the smooth afterwards? If we add more smooth? How does it look like on the DGA itself? Let's see here. Yeah, it's not helping. I bet there's a solution for this, but for now, we'll keep it like that. Okay, now let's go back to learning. Basically, more or less, that every point that's been processed inside of the each loop, or for each point loop, is a 0. It's basically the point 0. So what do we do to group that point and have it always work for us? We'll add a group right here, and that group will be called starts again. the same group from before, and that the base group will be 0, and this will basically take the point number 0. If we change it to points, the name of the group will be called starting points. Just so we have differentiation between this group and this group, because they will be quite different. Let's view that work here. All right, and the selected point is the 0 point, I suppose. Yes, 0 point. So it will always take the 0 point. That's awesome. Let's call this group starting points and add G big. Next step is to do group by range, so we can have our second group by range, so we can have our first and last point. We'll read your comment in a second. Group by range. Here we go. So NGE, good. Let's put that. Let's hook it up here. And we dealt with this before. We invert the range. We put it into points, and we add a 1 and a 1 on each. Actually, we don't 1 on the beginning because we have that already. So here we go. We'll just have on the end of that point 13 basically for this iteration. Good. So we have group now for the beginnings and for the ends of each loop, and it's grouping that over the process basically. Let's see what we can do afterwards and why we made those groups. And actually, let's put those two groups to the side so we can differentiate their status or what they do from the rest of the subnetwork. Okay, pause the recording again. So what we will do now, we are in the next episode in the video basically. We're doing great progress for today, and I'm going into speedrun mode because right now I only have 1 hour left of the day to stream. Fine enough. Okay, so what we need to do now is add noise to the whole shenanigans. So first, let's view it from above. Good. Let's go to our, so right after it had created or operated on the connection curves. Honestly, this is not an operation. This is a gen because it generates the connections. So we'll bring it back to be a generation. This is just organizational purposes, nothing else. So between the generation of the sweep, so right before the sweep happens, we need a subnetwork. Excuse me, right there. We'll call that subnetwork. What should we call it? Let's call it. Help me. Let's call it generate. So generate a noise. Actually, that is an operation. So operation noise, because it's not generating mesh or anything else. And we'll pull it right inside of here. What do we need first? We need for each connected pieces. So let's do that. So for each connected pieces, boom, connect the connection. Okay, wait, take everything, put it in line. Good, now make more space here because it will take some time or some effort to make this work. Add a new node, which will be a VOP node, VOP, attribute VOP, boom. So now we'll go into visual coding, basically. Double click on the mofo, and now we have our input and output, good, and our attributes. So in the middle, we need something called noise. Let's go with cellular noise or curl noise. Let's go with curl noise. Yeah, and we'll put the P into the position. We will take the noise and add it. We'll add from the position. Okay, let's put one more input. How to do that? How to do the add, Jack, come on, dude. Okay, here we go. And add our noise to it and then plug it in the position. And this should give us simple noise. But we want it to work a bit smartly. We wanted to do that work on each connected pieces, or each connected piece, so to speak. We can change some things, the amplitude, see that right there, keep it on 1. We can change the roughness. We could change the annuitation, the turbulence. That sounds fun. 3. Step size, surface effect radius. I wonder which one is the texture. This is surface, blah, blah, blah. Okay, let's just keep it like it is for now. And we will plug more functionality to it a bit later. So yeah, let's learn. is have the number of iteration of the loop affect the offset of the noise. So yeah, let's work on that. As we know from before, if we click on it and go to create meta import node, it will create us itself. But if we go into the details, we have iteration. So right now it's choosing iteration 78. Fine, let's plug this into the second input. And to access the second input, we need to call in input, let's see, subnet input connector. Now, wait a second, let me just go a little bit backwards to get you the proper answer for that. I forgot what the thing is called. Import detail. It's called import detail. Yes. And yeah, so this will give us the detail from our what is it called? Damn it. From the input 2, basically this one, from the metadata. And if I click on it and I go into integer right there, and I have second input, and now we have the input from it. And attribute, we could look for, all right, let's keep that to P for now. Let's go with the result and put it into something called, all right, so give me a break. Let's go and work on it. This thing will be hooked to a multiply constant, this one. What does it do? I hope I could read about it in the info. Multiply constant, vob, what does it do? Let's read about it inside of the help. And so we call out for help now. Let's check it out. I hope my mic still works. Let's just check if it does. All right, so simpler version of the multiply operator, does not require second input. Okay, so that is what it does, basically. Mic still works. That's amazing. Okay, so it does a divide. Okay, so it's a simpler version of it. Amazing. So we could do the multiplying right there, and we could change that to an integer if we want. But right now, okay, so what we need is to change the value here from an integer to a float. So int to float right there, and hook that thing in. So hook the result in here and have that inside of here. And now the actual result of the multiplication should go into the offset. So let's take this thing here, and it in the noise there's an offset. So every time it will go through an iteration, it will have a different number now. There's a couple of more things to change. Let me check. We are in speedrun mode. That's fine. We'll keep going with this thing. So let's get to it. So first thing we'll do is promote. So first of all, let's give this number some, yeah, it works. It goes on to 30. That's pretty good. Let's promote our frequency into, so that middle mouse click, promote to parameter, and click on it again. Double click on it afterwards, and get the amplitude also and promote it to parameter, so we could play with it afterwards. So we could play with those values outside of this. This is good for now. Let's let's go back and check on the thing. We could check on it here by each and every pass, and we can disable it again and basically play with the attribute binding, I think. Where can we play with the attributes? Okay, give me a second. They were just hiding beneath here, so it's fine. Yeah, so we can play with the amplitude on each iteration now. So we could take the amplitude down or more. It's acting pretty intense. We have to make this effect work less more intense. Okay, let's see what the next steps are. We'll be right back. I noticed that before. Basically, they missed it, but they fixed it now. So basically, let's go inside of the VOP again. Let's go inside of here into the import detail, and that's what I thought. We needed the iteration data. Good, now we have some nice results. I feel like that's a bit too much. We definitely, all right, so that is, I think, due to the amount of, let's see. I think that's due to the amount of amplitude. Now we could lower that down. No, not really. Frequency? Can we lower the frequency? Yeah, that could be it. Let's go with all three of them and lower their frequency to something like this. And now we're getting some interesting result. If I bypass it, it looks like this. It's way too big. Let's bring that thing to 0.5. Where was it before? Around here, backwards again, and check it out again. All right, so we will keep checking that and bring it back to where it belonged. Yeah, that's pretty much where we want it. Yeah, basically keep the amplitude to 0.01 or maybe 0.2. And now we can mess with our frequency pretty much. Yeah, that's pretty good. Let's mess with it here though. 0.1. Yeah, look at that. That's amazing. That's great. Yeah, I like that. We could also up the whole frequency quite a bit. So yeah, basically the more frequency, the more it looks like veins, which is the look we're going for. I pretty much like this look here. So yeah, let's definitely save and save it incrementally as well. So let's save incrementally. 4.5. This is amazing. Let's keep learning to do with this thing. Okay, so we need a curve view, guys. Where do we get our curve view? Well, a resample. Let's check where we could get that. Oh my god, look at that spaghetti. It looks pretty good. Work, 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 faster, faster, faster. Yes. I think the more you learn about something, the faster you get, and the more you could follow up faster. You're literally speed running into tech art. Yes, 30 days in. Let's go. World record, tech art, transitioning, I guess. All right, so let's go into generating connection curves. All right, so where was the last resample at? Okay, so it was right there. Let's get that resample curve view. Click it and save. Go back. And I don't know why I saved. I think I'm used to Unreal. Let's go into the operation noise. Now what we will do is get our curve view through a bind. So attribute bind. So we'll get that thing in, no, not this one. Attribute bind, attribute, wait, attribute bind. Let's see, bind. Find attribute value by index. Is that the one? Okay, let's just add a bind then. Fine, good. Let's get our curve view. How to do this? You basically call it curve view, and now you get it. Curve view, and the curve view is an integer. It's actually a float. It's actually a float because it does a 0. It adds a 0 value, 0.00000 on the 0 point, and on the last point it's 1, and in the middle or before it's 0.98, blah blah blah, etc. Okay, so it's a float, definitely. Let's pause. That's it for today. I'll have to go take care of some stuff. But yeah, thanks for watching. Subscribe if you haven't yet. Follow if you haven't yet. Appreciate you being here. Sproul, I'll see you around in the Discord server. Make sure to enable the ring role inside of Discord to know when I go live. Thank you so much. Have a good evening, you too. Bye bye. And yeah, everybody, check the what is it called, the playlist if you haven't yet. Join our Discord below in the link. DoubleJump Academy, pretty good course. Check it out also in the description below. All right, so everybody, bye. And now I have to click on stop 30 times.